All right, a car dealership knows it sells an average of 5 cars a day with a standard deviation of 2.25. It begins a new ad campaign and it sells 160 cars over the next 30 days. So with alpha equal to 0.05, can we say that advertising has helped boost sales? Again, let's go through all of our steps. What's our first step? Our first step is hypothesis. The hypothesis step means we write down H naught and H1. Our null hypothesis would be that the advertising hasn't done anything. So if there's no advertising, what do we expect the car dealership to have? We expect the car dealership to sell 5 cars a day because we know that's the standard for this dealership. If there is something going on, if our advertising has worked, the advertising has boosted sales, then that means that our average is actually bigger than 5. So we're going to do the null hypothesis that it's equal to 5, and that is that everything is as expected. But if we can prove that something interesting is happening, then that means that we'll have bigger than 5 to be our result. Okay, so now that we have our hypothesis, our next step is to look for our test statistic. And as we look through, we have to choose, do we want to use the Z or the T test statistic? And as I look at this problem, my problem tells me that it has a standard deviation of 2.25. That 2.25 is the standard deviation for what always happens. So that is a sigma value. So since we know sigma is known. Sigma equals 2.25. So which test statistic am I going to use? I'm going to use the Z test statistic. So Z equals x bar minus mu divided by sigma over the square root of n. And now it's a matter of reading all of my problems and fitting them in. Well, there's a little bit of a trick on this one in that x bar is not clearly told to us. But we do know we sell 160 cars in 30 days. So that information tells us what the average number of cars sold today. And what are the average number of cars? You just do 160 divided by 30, and that tells us that we sold 5.33 cars per day. So our x bar is that 5.333. Now we're comparing this to our mu. Mu is always from our null hypothesis, so that's a 5. And then we divide by our sigma, 2.25 divided by the square root of n. What is n? Well, how many experiments have they had? Well, we're selling cars, and we're selling cars per day. So days are an experiment. Think of each day as an experiment. You sell a number of cars that day. So we have 30 days because we've had 30 different experiments. So our n is 30. So these are our numbers. We need to go calculate that and see what we get for our answer. And let me type it in my calculator. So I'll do 5.3. I don't know if you can see this at all or not, but that's fine. Oh, I forgot my parentheses. And then I'll divide by 2.25 divided by the square root of 30. And I got 0.8106 for my answer. 0.8106. So that means that now that I'm ready to find my p-value, this 0.816 is going to be the answer that I work with. So that means I'm going to draw my normal distribution. I'm going to put my 0.8106 on here, and we're looking for a greater than, so that means we're looking at the right-hand side. So the right-hand side is what I'm going to shade. So my p-value is that number that falls right over here. Okay. So now as I'm ready to calculate this, I use normal CDF. Normal CDF, my lower is 0.8106. My upper is, tell you what, let's just write just any big number that you choose. Mu is 0, sigma is 1, and I type all of this in and get my answer. When I do that, normal CDF, 0.8106, some really big number, 0 and 1, and I get 0.2 0.087, so let's just do 0.209 for my p-value. So there's my p-value. So finally, the last thing I have to do is I have to come to a conclusion. And what I do is I compare this to my alpha, and in my problem it told me to use alpha equal to 0.05 for my comparison. And how does it compare? Well, p is bigger than alpha. And bigger than alpha means that this is not an unlikely event. This is a normal type of event. And since it's a normal type of event, we will not reject H naught. Our H naught will remain our default assumption. So we fail to reject H naught. So in practical terms, this means that we don't have evidence that the advertising has actually boosted sales. It doesn't mean it hasn't, but we don't have enough evidence in our data to say that it's made any difference. The sales, from what we can tell, aren't significantly different than what they were originally. All right, see you on problem 9.7.